So at this stage we know that electrons are in shells, and these are the major energy levels. With the energy of the electrons increasing, the further you get away from the nucleus. And there is a maximum number of electrons that can occupy any given shell, and this is given by the formula 2n squared, where n is the shell number. So for instance, shell number 3 would have 3 times 3 is 9 times 2, so 3 squared times 2, which equals 18 electrons. And that's the maximum number of electrons that can fit in that shell. So the outer shell always has a maximum of 8 electrons. This is one of the limitations of the shell model. Why is this so, that the maximum in an outer shell can only be 8 electrons? Other limitations of what the shell model doesn't explain is why shells have particular energies, or why electrons circle in an orbital rather than an elliptical motion. This is where Schrodinger came up with his quantum model, which was based on subshells and orbitals, and this is what the model looks like. So each shell has a subshell, and these are energy levels found within the shells. These are labelled as S, P, D and F, with S having the lowest amount of energy and F having the highest amount of energy. So each shell can be divided into these different subshells, depending on the number of subshells will depend on the shell, but I'll explain that now. The first shell only has one subshell, and this is the 1s subshell. The second shell has 2 subshells, and this has the 2s and the 2p subshell, because these are the lowest of the energies. The third shell contains 3 subshells, and these would be an S subshell, a P subshell, and a D subshell. And the fourth shell contains 4 subshells, the S, the P, the D, and the F subshell. That's all the subshells we have, so that the fifth shell also only contains 4 subshells, which is the S, the P, the D and the F subshell. The sixth one would still only contain these 4 subshells. So note that the first subshell contains 1, the second contains 2, which is 2S, 2P, the third contains 3 subshells, 4S, 4P, and 3S, 3P and 3D, and from there on they all contain each of those subshells. So here is a diagram showing the first shell, the second shell and the third shell. The first shell here contains 1 subshell, and that's called the 1s subshell. 1 meaning that it's in the first shell, and S meaning that it is that subshell, the S subshell. The second shell contains 2 subshells, and these are the 2S and the 2P subshells. The 2 representing that it's in the second shell, and the S representing the S subshell, the P representing the P subshell. The third shell here contains 1, 2, 3 subshells, and these are the S, the P and the D subshells. So here's just another representation of what we've been talking about. The first shell contains 1 subshell, and this is the S subshell. The second shell contains 2 subshells, and these would be the S and the P subshell. The third shell contains 3 subshells, and it is the S, the P and the D subshell. And the fourth shell contains 4 subshells, S, P, D and F. I would recommend that you try and remember some way of remembering these letters in this order. Used in previous years, I've had Sophie Peters doesn't fail. Another good one I've had was Sarah pees during French. So see if you can come up with something, a way that you can remember the order of those subshells. Okay, our last regions are regions within a subshell, and these are called orbitals. So each subshell has a certain number of orbitals, which are again regions of energy. The S subshell contains one orbital, the P subshell contains 3 orbitals, the D subshell contains 5 orbitals, and the F subshell contains 7 orbitals. This is important because, according to the Pauli exclusion principle, an orbital can contain a maximum of 2 electrons. So each of these orbitals here can contain 2 electrons, or a maximum. It can have less than 2, so it can have 0 electrons, it can have 1 electron, but the most each can have is 2 electrons. So the S subshell contains 1 orbital, which we know. Each orbital can contain 2 electrons, so the S subshell can contain a maximum of 2 electrons. The P subshell contains 3 orbitals. Each orbital holds maximum of 2 electrons, so the P subshell can hold 6 electrons. The D subshell contains 5 orbitals. Each orbital can hold a maximum of 2 electrons, 5 times 2, so the D subshell can hold a maximum of 10 electrons, and the F subshell contains 7 orbitals. Each of those orbitals can hold a maximum of 2 electrons. 7 times 2 is 14. So the F subshell can hold a maximum of 14 electrons. So let's have a look at the different shells of an atom. The first shell can have one subshell. It's the 1s subshell. This contains one orbital. 1 times a 1s orbital. Remember, each orbital can contain, or an s orbital can contain, 2 electrons. Thus, the 1s subshell can contain 2 electrons. And this fits into our rule and explains why the first shell can hold a maximum of 2 electrons. Let's have a look at shell 2. So the second shell contains 2 subshells. The first of those is the 2s subshell. The s subshell always only contains one orbital because it's an s subshell. So each of those orbitals can contain 2 electrons, so we have a maximum of 2 electrons in that subshell. The second subshell is the p subshell. This contains 3 orbitals. Each orbital can hold a maximum of 2 electrons, so it's 3 times 2p orbitals. We have 6 electrons. So now we have a total of 8 electrons in the second shell. This again fits in with our maximum 2n2, which equals 8. Let's have a look at the third shell. So the third shell has 3 subshells. The 3s subshell, which contains 1 orbital, which therefore contains 2 electrons. The 3p subshell, which contains 3 orbitals, therefore 2 in each, gives us 6 electrons. And we've got the 3d subshell. It contains 5 orbitals, so thus we have 10 electrons. So this gives us a total of 10 plus 6 plus 2, which is 18 electrons. And again, this fits in with our maximum rule. This will work for any of the shells if you work them out like this. So the fourth shell, I'll run through this one quickly too. Fourth shell, 4 subshells. There's the 4s subshell, contains 1 orbital. Each orbital has a maximum of 2 electrons. 1 times 2 is 2. The 4p subshell contains 3 orbitals. 3 times 2 is 6 electrons. The 4d subshell contains 5 orbitals. 5 times 2 is 10 electrons, and the 4f subshell contains 7 orbitals. So there's 14 electrons there, which then gives us a total of 32 electrons, which again fits into the 2n squared formula. Okay, so I've written them out like this to hopefully make it make a little bit more sense to you. So the first shell here has an s subshell, 1 orbital, 2 electrons, and it's written as 1s2, meaning it's in the first shell, it's the s orbital, and the s orbital contains a maximum of 2 electrons. You can see each of these s orbitals contains a maximum of 2 electrons. This is the 4th shell, this is the 3rd shell, this is the 2nd shell. So the 2nd shell has an s and a p orbital, the 3rd shell has 3 orbitals, which are the s, the p and the d, or subshells I should say, and the 4th shell has 4 subshells, which are the s, the p, the d and the f. The s subshell has 1 orbital, the p subshell has 3 orbitals, the d subshell has 5 orbitals, the f subshell has 7 orbitals. Each of these orbitals can contain 2 electrons. 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10, 7 times 2 is 14. And this is why it's written 4s2, the 4th shell, the s subshell, and 2 electrons can fit in that. The 4th shell, the p subshell, 6 electrons can fit in that. The 4th shell, the d subshell, 10 electrons can fit, and the 4th shell, the f subshell, and 14 electrons can fit. There is an order in which these shells are filled, and this is the Aufbau principle, which allows electrons that will enter orbitals of the lowest energy first. And this is a diagram showing the lowest or the energy of the different subshells. We have lowest energy on the bottom, highest energy on the top. So they fill up, or they have energy in this order: 1s, 2s, 2p, 3s, 3p, and this is when something bizarre happens. The energy levels start to cross over. 4s, 3d, 4p, 5s, 4d, 5p, 4f, and they fill up in an out of order way. And this explains why until now we've only been able to work up until calcium, because calcium forms in this region here. When this is written out, it fills up in this order: 1s, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10. And this is where I'm talking about calcium, because if you count the electrons, 2 plus 2 is 4, 10, 12, plus 6 is 18, and then you get 2 in the 4th shell, which is calcium, and then the 3rd shell starts filling up again. How do you work out the order of these filling up? You don't need to memorize this diagram on this page. There's an easy way of doing it. Okay, so the order of filling, you don't have to remember this diagram here. There's an easy, simple way of doing it, and this is the way that I do it. Write these down in the order so you know that there's 1s in the first one, 2s, 2p in the 2nd shell, 3s, 3p, 3d in the 3rd shell, 4s, 4p, 4d, 4f in the 4th shell, and you've got the spdf, spdf, and it just continues onwards like that. So make sure you write them nice and neatly in straight lines like this. Then you can put arrows, draw arrows through in a diagonal way, as I've just done here. Okay. Now follow the arrows down. So here, and we know it's 1s2. Next in order, is 2s2. Keep following the line. Start at the top of the line. So we've got 2p and 3s. Next, we've got 3p and 4s. Next, we've got 3d, 4p and 5s. 3d, 4p and 5s. Next, start the top of the next line again. You've got 4d, 5p and 6s. 4d, 5p, 6s. Start at the next line. You've got 4f, 5d, 6p, 7s, and on it goes. You'll never really have to work out anything much past about 5p. But you need to know how to draw this. Okay, so working these out. Example number 1 asks you to draw aluminium's ground state electron configuration. Aluminium is element number 13. So there's 13 electrons. So there's 2 in the 1s, 2 in the 2s, that makes 4, 6 in the 2p, 2 in the 3s2, and then 1 in the 3p. So it's 2, 4, 10, 11, 12, 13 electrons. And we're just putting them in order that they are here. 1s, 2s, 2p, 3s, 3p. 2 in the s subshell, 6 in the p subshell. Let's have a look at sulfur, element 16. So we've got 1s2, 2s2, 2p6, 3s2, 3p, 4. This is our next one here filling up. So we've gone 1s, 2s, 2p, 3s, and 3p. We've got 2, 4, 10, 12, 16 electrons. Neon, 10 electrons we need. So again, just write them in order. 1s, 2s, 2p. 1s, they both S subshells can only hold a maximum of 2. And the P subshell can hold 6. And calcium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. All I've done is 1s, 2s, 2p, 3s, 3p, 4s. 2, 4, 10, 11, 12, 18, 20 electrons. Okay, example number 5. Here we have iron and we have the iron. The iron having lost 2 electrons. We need to be really careful here as to where the iron has lost the 2 electrons. So let's look at normal iron, the iron atoms electron configuration. So we've just gone again through the lines as we always do. 1s, 2s, 2p, 3s, 3p, 4s, 3d. And that's the order they come up here. So you've got S is 2, S is 2, P is 6, S is 2, P is 6, S is 2, and D is 6. Because that will give us 2, 4, 10, 11, 12, 18, 20, plus 6 in that shell that does not have the maximum number of electrons in the D shell. The maximum number would be 10. So it's the D shell that's being filled. Okay, notice that they're out of order the exact way that they are listed here. So when it loses 2 electrons, it's going to lose 2 electrons from the D subshell, from the higher energy subshell. So this gives it a configuration now of 3D4 because it's lost the 2 electrons from the 3D subshell. Have a look at gallium here, and I'm going to show you the last thing I need to, which is that these can be written in shell order. So let's have a look at just following what we've been doing. We have the 1s, the 2s, the 2p, the 3s, the 3p, the 4s, the 3d, and the 4p. So this is what I've just done in order here. The shells are not in order here. You've got the first shell together, the second shell together, the third shell, and this is where it starts filling up in different stages. It fills up the third shell, or the fourth shell before it starts filling up the third shell, and then some more of the fourth shell. What it can be listed as is like this, with its shells together. So you've got the first shell, the second shell, the third shell, and the fourth shell. You need to be very careful at this point here to realise that the 4s subshell has lower energy than the 3d subshell, as it's listed here or shown up here. So the 4s subshell has less energy than the 3d subshell. So just be really careful that if you're taking electrons away or filling shells up, because you're looking at ions, is that you make sure that these are in their energy order, because it's the 4p1 shell here that's filling up. This is obvious, but if you got rid of the 4p here, you wouldn't be too sure which one here had the higher energy level, whether it was the 3d or the 4s. So always write them in the order that they are here first, and then neatly rearrange them into shell order here. But if you ever see a question that's giving it to you in shell order, rearrange it into the proper energy order so that you know where the electrons should be, what the ground state and lowest energy of those electrons are. So I've got a couple of questions for you to answer here. Give the video a pause and see if you can work out the electron configurations for beryllium, fluorine, nickel and tin, and I'll run through the answers. So beryllium has got 4 electrons, and they will be in 1s, 2 in the 1s, and 2 in the 2s. So 1s2, 2s2. Fluorine, 1s2, 2s2, 2p5. That gives us 2, 4, 9 electrons. Okay, so nickel, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d8. Now remember, to put it correctly, you have to put the shells together. So here I've just moved the 3d and all the 3's are together, and there's 4s2. But it's the 3d subshell that is the last to be filled. Tin. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 5d10, 5p2. I've just followed this here. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. And back to the top again. 4d and 5p. Now remember, we rearrange it so that the shells are all together, so this answer looks like this. But again, make note that these are the different energy orders in which they fill, and it's the 5p that's getting filled at the moment. Okay, so you've got a couple of booklet questions there for you to complete, and some chapter questions for you to complete, but you'll have time in class next lesson to do those.